with a red pencil, on the front side of our 6, I'd like you to make a divider between the positive ions and the negative ions. So on R6, on R6 on the bottom, please make a red line right through the space between group 3 and group 4. So a red line, and continue that red line all the way down to the bottom of the page. So for the top of the page, you have a group 3 and a group 4.
You said boron and carbon?
And then a red line right between group 3 and group 4, all the way down to the bottom of the page.
R6?
On R6.
Let me see what it looks like.
This?
Alright, please take a look. The reason that I chose red, is to split those two sides, is because on our periodic table we have the red stair-step line splitting the metals on the left and the non-metals on the right. So if you look at this diagram, what you will see is over here you have all the metals. The way we know that they're metals is they are forming positive ions because metals give away electrons. And over here, we have the nonmetals, and we know they're nonmetals because nonmetals are gaining the electrons to become negative ions. So now what we're doing is we're looking at the pattern or trend, what happens when atoms lose electrons like the nonmetals, and atoms gain electrons like the nonmetals. Atoms lose electrons like the metals, and gain electrons like the nonmetals. Alright, so over here, what we're going to do is we're going to write the word metals. Write the word metals. I want you to notice that everybody in group 1 was becoming a 1+, and everybody in group 2 a 2+. They are the same group or column or family because they behave the same. So metal, what typically happens with metals is if you look at an example of sodium. Sodium with a certain size, and then the sodium ion with a smaller or larger size. Sodium with a certain size, and then sodium ion with a larger or smaller size.
Smaller.
Smaller size.
What
So
would these be?
metals generally get smaller. Metals generally get smaller when they become ions. Now, not only are we going to identify the trend that just happened, they generally get smaller when they lose electrons, but now we're going to explain why that happened. So take a look at sodium with this 2 electrons there, and 1, 2, 3, 4, 5, 6, 7, 8 electrons here, and 1 on the outside. When that atom with 3 energy levels loses an electron, this electron leaves, then all of a sudden that third energy level is empty. That third energy level does not exist, and now it's only got 2 energy levels instead of its original 3. So what we've been writing about in our paragraphs, and especially in our quantum mechanics paragraph, is when those metal atoms lose electrons, what happens is you are emptying your last energy level. You're emptying it out and you're dropping back to the previous energy level. And so these metals generally get smaller, and the reason why we're going to put underneath. Lose the valence electrons. Lose the valence electrons. And move down to previous energy level. So the metals generally get smaller. They're losing those valence electrons, those outermost electrons, those bonding electrons, and they move down to the previous energy level. So typically, metals losing electrons get smaller. They have less number of energy levels. On the other side, what you will notice is nonmetals, when they turn into ions, the size of the nonmetals generally get larger. Now, the question about why they generally get larger. So, we're going to deal with chlorine, number 17. Chlorine has 3 energy levels, just like sodium does. But what's more important about chlorine is the outermost, where there are 7 electrons. 2, 4, 5, 6, 7. And so what happens is, remember, these electrons do not like each other. These electrons are spreading out as far away from each other as they possibly can. They're still pulled into the nucleus from the positive attraction, but they're spreading out as far as they can. And so now, all of a sudden, another electron comes in, a new electron, and now these electrons want to move away from each other as far as they can, and so the ion actually gets bigger. You're still in the same energy level. It's not the same over here where you're getting rid of an energy level. Over here, you're not gaining an energy level. But what's happening is those extra electrons, whether they be 1, 2, or 3 extra electrons, these electrons move away from each other as far as they can, and the atom gets bigger. So, what we will say is, added or gained electrons move away from each other. Repel. Should we put repel in parentheses? Move away from each other, repel each other. So the atom gets bigger because of that. So that's the trend for these ions for metals versus nonmetals. Metals generally get smaller because you're losing an energy level. Over here, the nonmetals generally get bigger because the added electrons try to move away from each other as much as you can. Alright, good.